Alright, this is page 110. And the title is Adding and Subtracting Rational Expressions. Adding and subtracting rational expressions. So last class we worked on multiplying and dividing rational expressions. Today we're going to work on adding and subtracting them. My directions say, what is the sum? State any restrictions on the variable. And I have x divided by x minus 1 plus 2x minus 1 divided by x squared minus 3x plus 2. Now me personally, when I add or subtract fractions, I like them to be written like vertically instead of horizontally like this, just because that's the way I learned how to add fractions. So that's the way that I'm going to rewrite them, vertically. But when I do, if anything can be factored, I'm going to factor that, okay? So my first fraction, x over x minus 1, can I factor any of that? No. So I'll just write that on top. Plus, in my second fraction, can I factor 2x minus 1? No. So plus 2x minus 1 over, but I probably can factor x squared minus 3x plus 2, right? It's a quadratic. So if I can factor it, I'm going to. So I'll do that over on the side. So for x squared minus 3x plus 2, a is 1, b is negative 3, and c is positive 2. So I need two numbers that multiply together to give me a times c, which that'll be a positive 2, and then add together to give me b, which is negative 3. Let's see. Negative 2 times negative 1 is positive 2. Negative 2 plus negative 1 is negative 3. Perfect. So that's going to be x minus 2 and x minus 1. Okay, you know when you add and subtract fractions, you have to get a common what? Denominator. Okay, so we just have factors in our denominator. All right, so the way I think about it is, this fraction has a denominator of x minus 1. This fraction has a denominator of x minus 1 and x minus 2. I need one of all of those factors to be a common factor. Okay, so my least common denominator, I'm going to need an x minus 1 and an x minus 2. I've got two x minus 1s. You don't need to repeat them, because that'll be a common denominator. It just won't be the least common denominator. You'll just be causing yourself more work. Okay? So just like when you add regular fractions, we need equivalent fractions with a common denominator. So in my bottom fraction, what did I multiply my original denominator by to get my new denominator? It was a 1, right? There's nothing that's changed. So if I multiply the denominator by 1, then I have to multiply the numerator by 1 to get an equivalent fraction. So basically up here nothing changes. So we have plus 2x minus 1. Now in my top fraction, what did I multiply x minus 1 by to get x minus 1 times x minus 2? X minus 2, right? I just look at the which of the factors are missing. So if I multiply the denominator by x minus 2, I have to multiply the numerator by x minus 2 in order to make an equivalent fraction. So you could either go ahead and multiply them out there, or right at this point I just rewrite it. So this is going to be x times x minus 2. So remember, when you add and subtract fractions, you don't add and subtract the denominator, you just bring those down. My numerator, I could either bring it down like it is, or I could go ahead and multiply it out. I'll just go ahead and multiply it. So x times x is x squared. X times negative 2 is negative 2x. And then I'm adding 2x minus 1, and I don't really need that parentheses there because I'm just adding it, so just plus 2x minus 1. Now, my numerator's in standard form, well, almost. I can cancel out some terms there. And my denominator's in factored form. We need them both to be in factored form so we can see if there's anything else we can cancel out. All right? So in my numerator, I can see negative 2x and positive 2x make 0. So I'd be left with x squared minus 1. And can I factor x squared minus 1? Yeah, it's the difference of two squares, right? So really quick, before I do that, I'm going to go ahead and state the restrictions so I don't forget anything before I start canceling. X cannot equal what? Positive 2 and positive 1. Because that would turn my denominator into a 0, and your denominator cannot be a 0. So for my numerator, difference of two squares, x minus 1 times x plus 1. And then I have those two common factors. X minus 1 divided by x minus 1 is just 1. So I'm left with x plus 1 times x minus 2. Can I cancel those factors? Those x's? No. Because they're part of binomials, right? If you're tempted to do so, put parentheses around them so that you know everything inside the parentheses has to be just like everything else inside parentheses before you can cancel. And that's it. Short and sweet, wasn't it? Any have questions on that? Did I go too fast? I did? All right, I'll slow it down next time. All right, page 111. We're doing the same thing. We're going to add these two rational expressions together. So we have x plus 1 over x minus 1 plus a negative 2 divided by x squared minus x. All right, so for my first fraction, can I factor either the numerator or the denominator? No. So I'm just going to rewrite that. X plus 1 over x minus 1 plus my second fraction. There's nothing I can do to the numerator, so I'll just write a negative 2 over How about x squared minus x? What's in that one? GCF, right, of x. So I can factor out of x. And then x squared divided by x would be x. And negative x divided by x would be a negative 1, right? So I have three factors. X minus 1 is the same in both of them. And then I also have an x. All right? So my least common denominator would be x times x minus 1. Because this x cannot count the same as this x. This factor is different than x minus 1. Right? So to get equivalent fractions, I'm going to see what I need my numerators to be when my denominator is x times x minus 1. Everybody with me? Am I done anything confusing yet? Okay, so my denominator, am I going to have to multiply by anything? No, because they're identical. So if my denominators are identical, then my numerator is not going to change. In this fraction, what did I have to multiply x minus 1 by in order to get x times x minus 1? An x. So if I multiply the denominator by x, then I have to multiply my numerator by x in order to get an equivalent fraction, just like we do when we add regular old fractions. 1/2 plus 3/4. You got to get a common denominator, and you have to get equivalent fractions before you can add or subtract. So up here, that's going to be x times x plus 1. You could go ahead and multiply it then, or you could just wait. And now I just add my two fractions together. So don't add the denominator. My numerator, I'm going to go ahead and multiply this. X times x is x squared. X times positive 1 is positive 1x, or just positive x. And then plus minus 2, that would just be minus 2, right? What do you think I could do at this point? Factor, right? My denominator is already factored. My numerator, I created a quadratic trinomial. So if I can factor that, I need to, because we might have some factors that can cancel out, okay? So my A is 1, B is 1, and C is negative 2. So I need two numbers that multiply together to give me AC, which is negative 2, and two numbers that add to give me B, which is positive 1. Okay, 2 times negative 1 is negative 2, and 2 plus negative 1 is positive 1. So my numerator factors into x plus 2 and x minus 1. Real quick before I cancel anything out and forget, my restrictions, x cannot equal what? 1 and what about this x? If it was a 0, right? 0 times 0 minus 1 would give me a 0. So x cannot equal 0 because of this x, and x cannot equal positive 1 because of this x. All right, and then we can see we have like factors of x minus 1. So we are left with x plus 2 divided by x. Can I cancel those x's? No. Nope.
Okay, so you can cancel the x minus 1 even though the x in the denominator doesn't go with it?
Right, because x minus 1 is a factor. This x minus 1 is a factor. If you have a binomial or trinomial or whatever, To cancel it, it has to be identical. You have to cancel the whole thing or nothing. Down here, this is a binomial, this is a monomial. So your factors have to be identical.
No, I was talking about before you got to the last step. X times x minus 1.
Yeah,
That x doesn't go with the other x.
correct. I mean, I could multiply them together, but you want to cancel when everything's factored out because you can cancel like factors. Okay, so they're two separate factors. But remember, with monomials, you can cancel within a monomial. It doesn't have to be identical. Like we had some of this last class. If I had 5x times x plus 3 over 10x over x minus 1, let's say. Now, x plus 3 and x minus 1, they're not going to cancel, right? But 5x is a monomial, 10x is a monomial. When you just have a monomial divided by a monomial, we can reduce within that. Okay? Like 5 goes into 5 once, 5 goes into 10 twice, and then your x's would cancel. So you'd be left with x plus 3 over 2 times x minus 1. So the monomials are the only time that you can reduce within it. It's not an all or nothing. But if it's a binomial or a trinomial or a polynomial of 4 terms, the whole thing has to be exactly the same in order to cancel it.
Thank you.
You're welcome. Do you have any other questions? Okay, so now I'm going to do 2 more just like this, but they're going to be subtraction problems. You do the same thing, except for you're subtracting the second fraction. Page 112. Directions say, what is the difference of the 2 rational expressions in simplest form? What is the difference of the 2 rational expressions in simplest form? State any restrictions on the variable. If anybody's going to be retaking the PERT this spring or summer or whatever before next school year, if you're trying to do dual enrollment in math, definitely I would go back over this section that we're doing now, this module that we're on, and the last module for sure before you take that PERT, because it loves rational stuff. Okay, so again, this is just exactly the same. We're just subtracting the fractions instead of adding the fractions. All right? So in my first fraction, could I factor the numerator? Nope. I'm just going to rewrite it. Could I factor the denominator? Yeah, I can see that it has a GCF, right? So let's start by factoring that out. What would it be? X. So if I factor it out, what would I have left? X minus 2. Now we're subtracting. Can I factor x plus 2? No. I am going to put a parenthesis around it because if we don't, sometimes we just think we're just subtracting the x, but you're subtracting x plus 2. So that negative would distribute, right? Over GCF of 2, factor it out, what's left? X minus 2. So my least common denominator, I have a factor of x, x minus 2, and 2. So you can either write it as 2x times x minus 2, or sometimes if that's going to confuse you, just think about them separately. And make sure you've included one of each factor in the denominator. Do we understand how to do the least common denominator? No? Yeah? No? Okay. My denominator's factors up here are x and x minus 2, right? My factors down here are a 2 and an x minus 2. I need one of each factor in the least common denominator. So I needed a monomial of x, got it. I need an x minus 2, got it. I need a 2, got it. I already had an x minus 2, so I don't want to repeat that. Okay? And that's all, just one of each. So that when I make my second fraction, alright, so if I'm looking at my bottom fraction, I've got my original fraction had a factor of 2 and x minus 2. My new fraction has a 2, an x, and an x minus 2. What am I missing? An x. So that's what I would have to multiply my original denominator by to get my new denominator, right? So if I multiply the denominator by x, to make this an equivalent fraction, I have to multiply my numerator by x. So I'm subtracting, so minus all of this. X times x plus 2. I'm going to go ahead and multiply it out. So x times x is x squared. X times positive 2 is positive 2x. So I have to remember to distribute that negative when I go on to my next step. Everybody okay with that? Okay. My fraction up here, my original denominator has an x and x minus 2. My new denominator has a 2 and an x minus 2. What am I missing?
2.
A 2. So I'd have to multiply the denominator by 2 to get my new denominator, which means I have to multiply my numerator by 2 to get to my new numerator. So I can just write it separately, or I'm just going to go ahead and distribute it, or multiply it. 2 times x is 2x. 2 times positive 2 is positive 4. Okay, denominator. I'm just going to write that as a 2x times x minus 2. My numerator, I have 2x plus 4 minus, I'm just going to distribute now. So negative times x squared is minus x squared. Negative times positive 2x is negative 2x. My numerator, 2x and negative 2x make 0. And then I have a minus x squared and a plus 4. Do I like my leading coefficient to be negative? No. So if I factor out a negative from my numerator, factor out a negative 1 or a negative x squared divided by negative 1 is x squared. Positive 4 divided by negative 1 is negative 4, right? And what's x squared minus 4? Difference of 2 squares, so I can factor that further. So don't forget your minus sign. And then x squared minus 4 is x plus 2 times x minus 2. Let me state my restrictions real quick before I cancel out. X cannot equal what? What can this x not be? A 2, right? 'Cause 2 minus 2 is 0. So x cannot equal 2. And what about this one? A 0. Because if that was 0, 2 times 0 is 0. 0 times 0 minus 2 would be 0. So So it would turn the denominator to the 0. Okay, is this my answer? Nope, because I have like terms here, right? Two factors that are identical. So x minus 2 divided by x minus 2 is 1. So we're left with negative times x plus 2 all over 2x. And the answers that they give you, maybe they distribute the negative, maybe they don't. If it's multiple choice, you just got to look and see how they leave their answer. Probably, I would think like this, but you never know. Y'all catching on? Good. Really, it's all about factoring. You can factor, it's not too bad. If you're still not good at factoring, then it's going to make it a struggle. But hopefully we all pretty much have the factoring thing down at this point. All right, page 113, I have one more. Then I'm going to give you some problems to practice on your own. We have x plus 3 divided by x minus 2 minus 6x minus 7 divided by x squared minus 3x plus 2. In my first fraction, I was not able to factor anything, so I just rewrote it. In my second fraction, can I factor the numerator?
No.
Nope. How about the denominator?
Yeah.
Probably so. I'll do that over on the side. So A is 1, B is negative 3, and C is 2. A times C is positive 2, and B is negative 3. Sounds good to me. Negative 2 times negative 1 is positive 2, and negative 2 plus negative 1 is negative 3. So that will factor into x minus 2 and x minus 1. What's my least common denominator going to be? X minus 2 times x minus 1, right? Then everything will be covered. I've got two x minus 2's. You only have to write it once. And then I've got an x minus 1. So in my bottom fraction, what did I multiply my denominator by to get my new denominator? Just the 1, right? Nothing changed. So I will be subtracting, in parentheses, 6x minus 7. What about my fraction up top? What did I have to multiply by my original denominator to get my new denominator? X minus 1. So I've got a binomial times a binomial there. You can go ahead and multiply it out now. You can start it off now. I can write it as two separate factors. It's up to you, but eventually we're going to multiply it all out. So I'll just start multiplying it out now. Okay? First times first is x squared. Outer times outer is negative x. Inner times inner is positive 3x. Last times last is negative 3. Now I can subtract my fractions. Again, my denominator, I just bring down. My numerator, I'm going to simplify that a little bit as I go. X squared, negative x plus 3x is plus 2x minus 3. The denominator, I'm going to go ahead and distribute that negative when I bring it down. So a negative times 6x is negative 6x, and a negative times negative 7 is positive 7. What do you think I'm going to do now with that numerator? I'm going to combine like terms, get it in standard form, and see if it can be factored anymore, right? Because I may be able to cancel out with some of those factors in the denominator. So I only have one quadratic term. My linear terms are plus 2x and minus 6x, so that makes minus 4x. My constants, a negative 3 and a positive 7, are positive 4. I think I'm going to be able to factor that numerator, so I need two numbers that multiply to get positive 4 and that add together to get negative 4. Negative 2 times negative 2? That works. What are my restrictions? Positive 2 and positive 1. X cannot equal positive 1 or positive 2. I've got slight factors of x minus 2 and x minus 2, so I'm going to cancel those out, and I'm left with x minus 2 divided by x minus 1. You can put parentheses, you don't have to put parentheses. Either way is correct. Anybody have questions on that? You confused about anything? All right then.